All right, so I finished my general announcements. Highlights are CFU 7 was passed back on Tuesday, so students have until next Tuesday to retake it. CFU number 8 was passed back today, but given the Thanksgiving break, they have until Wednesday, December 4th to retake that. Tomorrow, when students walk in, we will have no practice or warm-up time. You will simply walk in, turn in the yellow review packet, which counts as 10 free points, and then you'll take the test. Now, today's material, once again, there is nothing new. It's all practice. So I will not be lecturing the way I normally would. Instead, what I'm going to say is things like this. You've got 2 minutes to do problem number 1. It says, identify the characteristics of the graph of f of x equals e to the x below. Use proper notation. So I would hope we're at a point where this problem can be done relatively quickly. So take 2 minutes and answer this question. Go. All right, so students were given 2 minutes to complete this. The first thing I would have done actually is just take note of the fact that this thing levels out at the x-axis. So I would add that asymptote myself, but here are the answers. Questions. All right, in response to a question that came up, one thing I do want to point out. Okay, someone was asking in an earlier period about this asymptote. Okay, and what I wanted to stress was the first, let's just pretend for a moment this equation looked like, let me make that a little bit thicker so it's easier to see. Let's imagine that this equation looks like this. Then the first thing I would do is realize the asymptote is down here at y equals -4. And that would affect a couple of things. The y-intercept would be at -4. The the horizontal asymptote would be at y equals -4. The y-intercept would be at -3, and the range, therefore, would start down at -3. So keep in mind that depending on where this equation actually is located, like if I move it all the way up here to an asymptote of, say, +4, now you'd say, all right, the horizontal asymptote is y equals 4, the intercept is at 0, 5, and the range doesn't go any lower than 4. The range is 4, infinity. So understand that depending on where the function is, that can affect some of your other answers. All right, but that being said, let me go and move all that stuff back and move on. All right, turn the page. So this is the one problem that I said I was actually going to walk you through myself. Again, the 2 reasons are, in my opinion, this is the hardest problem we'll ever see. And number 2, problem number 5 is just like it. So you will have a chance to practice this yourselves. So this says in 1995, there were approximately 54 million mass transit users in the United States. In 2000, the number of mass transit users grew to approximately 90 million. Part A says change R that represents the rate of increase for the number of mass transit users. They give you the formula. Note the value of R should be correct to 3 places after the decimal point. Okay? So here's the bottom line. You're told that they started in 1995, I'm just going to call that 0, with 54 million. Then 5 years later, in the year 2000, they had grown to 90 million. This question is really about, can you take that information and plug it into the equation? Notice what they've told you is we started at 54 million. That's your initial value. Then they say 5 years later, that's your T, the population had grown to 90 million. You'll notice that I've highlighted and color-coded every single variable in that equation except for one, and that's R. And that's what this whole question is about. It's, can you set up this equation by using the information you were given? You were told we started at 54 million. 5 years later, we've grown to 90 million. Use that information to figure out, well, what would the growth rate have to be for that to work? Now, if you really wanted to, you could guess. I do not recommend this, but check this out. I could do this in my calculator. At 54 million, let me imagine the growth rate was 1%. What would it be in 5 years? Well, that's not enough. It was supposed to grow to 90 million. All right, maybe it's 2%. Let me try 2%. Well, that's still not enough. That's only 59 million. Maybe it was 7%. All right, we're getting closer, but we were supposed to get to 90 million. Everybody see what I'm doing? This would be a really long, really annoying way of doing it. I'm basically guessing what the rate might be. And then I'm seeing, okay, based on different rates, did we get to 90 million? I would not recommend this method at all. What I would recommend you do is set up the equation and solve. Does anyone recall what can you do first here to try to solve for R? What would you do to both sides? I agree. We would divide. What would you divide by? 54. Exactly. I want to get rid of that 54. So I'm going to divide both sides by 54. Now, if I do 90 divided by 54, I'll get 1.6 repeating. By the way, if you don't like my style of dropping out the millions, if you really wanted to write the numbers down like this, 90 million, and you wanted to divide it by 54 million, that has no effect. You end up with the exact same number. Okay, just in case anyone noticed that I didn't write down the millions, I just wrote down the number of millions. In any case, when you divide by 54, you get right here. Now, what's the next step? We're trying to peel back the layers to get R by itself. So what do I need to do now? Say again. All right, I heard something about the 5. What is the opposite of the 5th power? How do you get rid of a 5th power? We have that word, starts with the letter R. The root, the 5th root. I'm not going to call it a square root because that is the 2nd root. I'm just going to call it the 5th root. So what I end up doing is I take the 5th root of both sides. Now on the left side, I'm going to get whatever the 5th root of 1.6 repeating is. On the right side, the 5th power goes away. That's the whole idea. Now let me go ahead and type that number into my calculator. So I'm going to go to my calculator. Remember, to get that, you hit the math key. So if you hit the math key, the 5th option down is the variable root. That's your way of telling the calculator, I want a root, and I want to tell you which root to use. Now, for some of your calculators, you're going to get this annoying ANS thing that pops up. Not a big deal. Just put your cursor on top of it and type over it with the number you want. Then move your cursor on the inside and type the 1.667. And we end up with 1.10. I'm going to round that 7 to an 8 because it's followed by a 6. 1.108. That's what you get after you take the 5th root of everything. Now, how do I get rid of this plus 1? Because R still isn't by itself. How do you get rid of a plus 1? You would subtract. So I'm going to subtract 1 from both sides. Okay? Thank you, sir. I'm going to subtract 1 from both sides. And that's going to get me R is equal to 0.108. So now, if I go back to my calculator, I could actually test this. Okay? If I test this, I can say, all right, let me make sure that 10.8% is right. That's my final answer for the rate of growth. But here's how we test it. I started at 54 million. I'm claiming the growth rate is 10.8%. And if this is really accurate, then 5 years later, we should be at 90 million. And we are. Notice that's not exactly 90, but that's because this is a rounded value. Remember, it was like 0.1076 something, 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 something. So it's a slightly rounded value. We didn't get exactly 90 million, but it's close enough. So again, the reason I wanted to go through this question with you all step by step is because in my mind, this represents the single most challenging thing that appears on tomorrow's test, where you are given some information and you have to set up a formula and then follow a mathematical procedure in order to solve for the rate. Now, once you have it, I would argue the rest of this problem is really straightforward. You're told to write an exponential model in the form of y equals a times 1 plus r to the t that represents y is the number of mass transit users in the United States and t is the number of years. So notice, I am not going to plug in a number for t. I am not going to try to figure out y. I'm simply setting up the equation. So I'm going to plug in my rate, and I'm going to plug in my initial value. Okay, my initial value is 54 million, and the rate we found was 10.8%. Then when we jump to part C, it says use your model to determine how many million mass transit users were in the United States in the year 2015. Round your answer to 3 decimal places. Now here's the thing. I want to use this equation, but the question becomes, what number am I about to plug in for t? They're asking us to make a prediction in the year 2015. When was this data started? Go back to the original question. When did they start collecting data for this? What year? 1995. In the beginning, 1995, there were 54 million transit users. So I have to realize if I started in 1995 and they're now asking me to make a prediction in 2015, how many years later is that, folks? 20 years. So that is what I would argue makes C a little tricky. You need to pay attention to what are you plugging in for T. Okay? And we end up with 419 million transit users. Questions? All right, so I'm done lecturing. Like I said, most of this period is going to be on you all to do some stuff. So we're going to move to problem number 3. Problem number 3 says, identify the following functions as growth or decay. Provide a written explanation of your answers. Now, real quick, I'm only going to do 2 of these before I give you time to do the rest. Please pay attention to the fact that a lot of these have negative exponents. The first thing I would do with this first problem is flip the 7. That way I can rewrite the exponent as a positive. And then I realize, oh, that base isn't 7, it's 1/7. So the base isn't bigger than 1, it's smaller than 1. So this isn't growth, it's decay. Now, with the example directly under it, the exponent's already positive. It's 2x. You don't have to touch the base. The base is 9, which is greater than 1. This is growth. Okay? So take 2 minutes. See if you can complete the other 4. Go. Alrighty, folks. So again, this is your answer key. One thing I want to add just in terms of notes real quick, I would recommend you add this yourselves. I'm going to show the work to flip every one of these that has a negative exponent. That way you can understand better where some of my answers are coming from. This is not necessarily required. I could write this in green, technically speaking, but I would really recommend that you copy the work that I'm showing for each of the 4 problems that had a negative exponent. You have to pay attention to the fact that if the exponent is negative, you need to flip the base. Questions? All right, go ahead and turn the page, folks. Problem number 4 takes the whole page, so I'm going to give you a more significant chunk of time here. Here's what I want to warn you on. If you cannot do part A, that has nothing to do with your ability to do B and C. So if you read the question, you're not really sure what to say for part A, just skip it, go to part B, and do part C. Okay? So take 5 minutes. I'll warn you that is probably not enough time to finish the page unless you're really fast. So don't stress about the timer. Just get done what you can get done. Go. All right, so as you all were working, I went ahead and revealed the answer key to part A. The thing I want to stress is that if you have a formula like in this Mizrahi bank that's compounded annually or semi-annually or quarterly or monthly or weekly or daily, you are using the formula on this side because you know what n is. But if you see something that is compounded continuously, that doesn't have a value for n. You have to use the new base E formula. Okay? So for part B, this is what your work should look like. For part C, this is what your work should look like. Now, let's pretend for a moment you had no idea how to do part B and C. And this, right now, I'm sharing with you all a test strategy I give to my AP Stat kids all the time for the AP exam. Let's pretend you had no idea how to do part B or C, but you read part D and you understood the whole point in part D was to use the numbers you found to make a decision. Check this out. Even though the correct answer is the Mizrahi bank is better because that has more money, over here, I'm going to pretend I don't know how to do any of this. Here's what you could do. Make up a number. Just write down a number. It's not going to be the right number, but that doesn't matter. $1,300. Make up a number down here. $1,400. And then down here say, well, I'm going to choose the Oben and Lee bank because this number is bigger. Guess what? You're going to get full credit for part D. You're going to get all the points for part D. Even though you made up values that are totally wrong and you didn't show any work because I'm pretending you're stuck and you don't really remember how to do it, you can still get full credit in Part D if you just demonstrate that you read the problem and you understand what you're supposed to do. Okay, so you're supposed to have two numbers and then compare the two to make a choice. So again, and this is the same thing I say to my AP Stat Kits, just because you can't do Part A doesn't mean you give up. You go to Part B. Just because you can't do Part B or C doesn't mean you give up. You go to Part D. Do what you can do. Okay? Questions before we turn the page for one final time today? Just taking away my red writing that I don't need. Questions? All right, turn the page. So once again, in my opinion, this represents the hardest thing I would ask you to do on tomorrow's test. Now we have about 12 minutes, so I'm going to give you all 7 of that. Let's make it 6. I'll just cut it in half. I'm going to give you 6 minutes. Just see how far you can get in this problem. I would say 6 minutes should absolutely be enough time to do Part A minimally. You should be able to do Part A in 6 minutes. Okay, but once you do Part A, the other two parts kind of happen much more quickly. Get going. All right, so I gave students 6 minutes. I'm going to go through this relatively quickly because we've got about 5 minutes left. I want to give you some time to pack up. So again, when you read the original problem, they tell you in 2013, we started with 90 million. And then in 2018, 5 years later, we had 960 million. So this is the formula you'd set up. We started with 90 million. 5 years later, we got 960 million. If you divide both sides by 90, you get this. If you take the fifth root of both sides, you get this. The fifth root of 10.66, I'll show myself typing that in the calculator real quick. Okay, remember, you hit the math key. It's the fifth option down. I want the fifth root of, go over, 10.667. And I get 1.605. That would be equal to 1 plus r. So you subtract 1 from both sides, and you get the rate of growth was a little over 60%. So when you're writing your model, you need two numbers. What did you start with? 90 million. And what is your growth rate? So for those of you who weren't sure how to do Part A, I want you to take a moment and try to appreciate the fact that you 100% could have done Part B. All you had to do was say, I started at 90 million, and my growth rate is what Mr. Oben gave me in Part A, 60.5%. And then Part C is, well, use that model. In 2020, remind me again, when did this problem start? What year did they mention in the beginning? 2013. So it's 7 years later. So this is take your model from Part B, plug in the number 7, and voila, you've got your answer. So I want to be clear, once again, on tomorrow's test, if you have no idea how to do this, hear me, folks, make up a number. Make it up. R equals 0.3. That's wrong, but if you go down here and you put 0.3 here, I'm going to give you full credit because you showed how to set up a model. And if you use 0.3 here, even if the number you get is obviously going to be wrong, you're going to get full credit. So if on tomorrow's test there's a problem like this, if there's a problem like this in tomorrow's test, and you're stuck on Part A, skip it. Just make up a number and then set up your equation and use your equation. Demonstrate what you do know how to do. All right. That being said, we are done. Your homework again, this review packet is due tomorrow when you walk in. Thanks for watching. Have a good one.